So here we have a diagram of a plug. Figure 1 shows the 3-pin plug connected to a metal toaster. Name wire X, that's the one at the top here. It's got a live, we've got a neutral, and the third wire is the earth wire. Now you can tell it's the earth wire because it's got the stripes on it. In reality they're green and yellow, but just because they're striped we can tell which one it is. And it wants to know, what does wire X do? Does it provide extra energy? Well, we can't get extra energy from nothing, so that can't be right. Does it complete the circuit, prevent electric shock, or provide the current? Now live is what provides the current, but we normally say it provides the 230 volts potential difference. Neutral wire completes the circuit, and this earth wire, our wire X, is to do with safety. So it doesn't complete the circuit, it doesn't supply current, it prevents electric shocks. That's the whole point of the earth wire, it's a safety device. The toaster is plugged into a mains electrical supply, so we know it's a mains, and the potential difference between the live and neutral. A number you need to remember is this 230 volts. In the UK, we use 230 volts potential difference at a frequency of 50 Hz. That's a key point you need to remember. The mains electricity is an alternating supply. This means that the electrons change direction repeatedly. The battery is direct supply. That means the electrons just go around in the circuit all in the same direction. Figure 2, so these are oscilloscope graphs of an alternating supply and a direct supply. And it wants us to state two differences. Now if we look carefully at them, we can see this one, the alternating, it's changing direction, it's going up and down. So it changes direction. And we know it's changing direction because it then goes below this 0 mark. If it stayed above it, it wouldn't be changing direction. Here, because it goes below our 0 mark on our x-axis, or our equilibrium position, we know that it's changing direction. It is also changing magnitude. Your y-axis will show you a value. Because here on the direct, it is a constant value. Where here on the alternating, that value changes all the time. So it's changing magnitude, and when it goes through the x-axis, it is changing direction. Now here we have a graph analysis question. We've got some information at the top. Energy is transferred to homes by the national grid. Figure 3 shows the percentage energy loss, so energy loss as a percentage, for different years. And it wants to describe the changes, and you notice that it's 2 marks, so there's 2 key parts. If we look at the first and last point, well, overall there's a decrease. That'd be our first mark telling us the overall pattern. But if we look at the whole pattern, it decreases, and then after 2013 it starts increasing again. So it increases after 2013. With questions like this, you just want to keep your answers short and to the point. So here, it wants us to calculate the mean percentage energy loss using figure 3. So what we need to do is to look at the graph. Each one little square is worth 0.01. So we can just read each part. So here we have 1.92. Here we have 1.71. Here we have, so this one here is 1.72. Here we have 1.70. Here we have, we go across 1.74. It's easier here if you use a ruler to go across so you can see it more clearly. And finally we have 1.77. So I've now got all my numbers here. And what we need to do to work out a mean is add them all together and then divide by the numbers are. So we've got 1, 2, 3, 4, 5 lots of results. So we'd want to add them together and divide by 5. Now notice I've put it in brackets here because of BIDMAS. So we'll do the brackets first. If we didn't and put this into our calculators without brackets, it would only divide this 1.77 by the 5. You could also put all these numbers into your calculator, find out the answer, and then do that answer divided by 5. But in this particular case, it would give me 1.77%. And all we need to do is just to write that in our answer box. But be very clear when you're showing your working out. If you do make a mistake, you may get some points for your calculations.